you hear that, Lacey? Okay, we are going to graph these four equations on the same graph. Okay, and I'm gonna put some restrictions. Here's how it's gonna go. We're gonna graph this one when x is between -1 and +1. That's what that means, right? That means, how does that mean that?
Yeah.
Okay. Well, we could write it like this: x is greater than or equal to -1, and x is less than or equal to 1. So if you're looking, the and means it has to satisfy both conditions. So a number, if you put a number line right here, and you had 0, -1, and +1, if you had a number that was greater than -1, which way is that?
So if I know that, I
Right.
get that x squared.
No, what I'm saying is this is the restriction. Remember yesterday I wrote it like this. I said between
Oh, okay. I thought you
x,
were pulling that out of the y.
yeah, x is equal to -1 and x equal to +1. Yesterday I said between, -1 and +1.
Okay, I thought you were just pulling it out of that.
Yeah, you know what, you guys, we didn't have a bell work today. Don't worry about bell work today. Oh, you know what? Let's do this one as a bell work problem. Let's do this one as a bell work. Okay, here we go. That one is what between y equals x. Y equals x squared is between -1 and 1. Okay. The next one, y equals x squared plus 3, is going to be when x is a number between negative, or let's go like this, between 1 and 3, like that. But it includes 3, but not 1. Got it? And this one right here, we are going to say is a number where x is between -3 and -1. It does not include -1, but it includes -3. And this one right here, we are going to graph when x is from -infinity and -3, between -infinity and -3. Okay, we got it? Clean. Okay, I'll come and look at it. Okay, here you go, you guys. I want you to do this in your groups. This is all going to be on the same graph. Do you guys want a piece of graph paper for this? Okay, I'll give you a piece of graph paper. All on the same graph. This is your task to teach you what we're doing today. Okay, that's right. All four of these graphs are parabolas. And so I would use your calculator to help you out. I'd type y equals x squared into your calculator. I would go set your table up. Do you remember how to set your table up? Let me show you how to set your table up. I'm going to bring the calculator back here. I'm going to go to y equals. By the way, this is a quick way to turn off your stat plot. You go back up when you're on your y equals screen. You go up and highlight the stat plot, and hit enter, and it'll turn it off. I'm going to hit that clear. I'm going to move this over. Yeah, if you go up to it, highlight it, hit enter, and go down, it will be off. Okay, so I'm going to put x squared. You guys all know how to put x squared in your calculator, right? I'm going to hit zoom 6 to graph it. What is zoom 6? Hit zoom. What does 6 say? 6 has a standard window, so that gives me my standard window. Okay. I go to y equals x squared, right? Did you type that in already? Okay, hit your zoom button. Look at number 6. It says standard. Hit 6. for a standard window? Okay. All right. If yours is probably, some of you guys are probably saying error because you have your stat plot on, Shannon. One more time, watch. Go to your y equals. Go up. If that's dark, take it up there, hit enter, and go back down. If it's not highlighted, it's not on. If it's highlighted, it is on. Okay? Hit your graph, and that's what it looks like. Now, watch, you guys. All eyes right here. I know you guys. Some of you guys are in different areas, but I want eyes right here because I want to show you how to use the table again. Have I showed you the table yet? Oh, maybe I'm thinking of one of my other classes. Okay. So right here, you guys. What does it say above window? It says table set. That's where you set your table. So everybody hits second in the window, and it brings up your table set. Now, table start is where you want you to start from. You know, what we're doing is we're making a table like this. Okay? What do I want my x number to start off? Do I want to start it off at 1 or at 0 or where? I'm going to start it off at 1, and I'm going to go up in ones. See the second one? That means increment the table in ones. So now, look above the graph button. What does it say above the graph button? Table. So access your table. Second and graph. Access your table. Notice my table started at 1, then 2, 3, 4, 5, 6, 7. Notice my y1 is 1, 4, 6. I can even go backwards to check out what negative 1 is. Look I got 3 points from negative 1 to positive 1. I have negative 1, 0, and 1, and I have their values 1, 0, and 1, right? So I can go to my graph. I can plot negative 1, comma 1, which is right here. I can plot 0, comma 0, and 1, comma 1 right there. I have the part of my parabola that is going to be between negative 1 and positive 1. Okay? Do we understand that? Okay, then I'm going to go back to my y equals screen. Now I'm going to type in x squared plus 3. I'm going to type that one in. I'm going to hit graph. By the way, what happened to my graph? From x squared to x squared plus 3. Moved up 3. Okay? Looks like it could be, yeah. And so I'm looking at that one now. And this one, I want to graph it between 1 and 3. Well, you guys look. Right here. Here's 1. I'm going to draw a line straight up going up 1. Here's 3. I'm going to graph the portion of the graph, this portion of the graph that's between 1 and 3, right? But it's easy if you go to the table. I already set up my table that's kind of close to where I need it. So on my table, I want between 1 and 3. So I'm going to look at 1. What's the value at 1? What's the y value at 1? So 1, comma 4. Everybody go to your thing and go to 1, comma 1, 2, 3, 4. You want to put a hollow circle at 1, comma 4. Why a hollow circle? Because it can't be 1, because if this is going to be a function, my first graph included 1, right? So notice that the first graph had a solid circle at 1, comma 1. Okay, then I look at 3, because I'm going to 3, 3, comma 12. So I'm going to go to 3, comma 12. 1, 2, 3, up to 12 would be about right here. And I'm going to have the portion, now remember this is kind of a curve, right? This is part of my parabola from there to there. So that's what my graph looks like so far. All right, I want to see if you guys can finish the rest of it. I'm going to make this a bigger screen so you guys can see that a little bit better. See how so I had, the first graph was x squared, and I only wanted it between negative 1 and positive 1. This second graph, I wanted it from 1 to 3. Notice that I put a hollow circle at 1, comma 4, because we can't include that number, but on 3, comma 12, I include the point because that's what it asked for. Okay, see if you can do the last two. Let's look at this, you guys, again. If you went to your table for number x squared minus 2, x squared minus 2 is a parabola that starts down here, and it goes up this way and up this way, okay? Does everybody know that? Except for I don't want the part of the parabola that's between negative 1 and 1. I want the part of the parabola between negative 3 and negative 1, right? So I'm going to go to negative 3. Wait, is that the one we're on? Between negative 3 and negative 1. So I'm going to go to negative 1 on my table. Look at your table. What does your table show at negative 1 for the x squared minus 2? Negative 1 comma what? Is it negative 1 comma? Where is it located, you guys? Some of you guys aren't catching on what I'm saying here. Look. If I go to my y equals, I'm going to change this to minus 2, right? Is that the equation we're on? I look at the graph. Look at the graph of it. But I only want from negative 1. So if you look at the table, I've already got my table kind of set up for this. At negative 1, when my graph is negative 1, when my x is negative 1, my y is negative 1. So I'm going to go to negative 1, negative 1. I'm going to put a hollow circle at negative 1, negative 1. Why is it hollow? Yeah, it says x is less than negative 1. It doesn't say less than or equal to negative 1. So then I find another point over here. My endpoint is negative 3. So I'm going to go to my endpoint negative 3. So when x is negative 3, y is 7. If I'm looking at my table, negative 3 comma 7. So I'm going to go to negative 3, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. And I'm going to go up like that. It's a solid circle. Number 7. I'm going to make this bigger so you guys can see it. It's going to look something like this. Do we understand that? Okay, now my last one is x squared plus 2x minus 5, and it's from negative infinity to negative 3. So I'm going to go to my graph. I'm going to keep that big for right now. I'm going to go to my y equals, and I'm going to put in x squared. What was my graph again? X squared, my equation. Plus 2x minus 5. Okay, I hit my graph button. There's a picture of my graph. It's off to the left a little bit, isn't it? Okay, I look at my table. Which number do I want to look at my table? Negative 3, because if you look back here again, this is the restriction, negative infinity, negative 3. So I got to look at negative 3, which is the right endpoint of that. So I go back over here and I find at negative 3, the y value is negative 2. So negative 1, 2, 3, negative 2. Is it hollow or solid? It's hollow because it doesn't. It says x is less than negative 3, not x is less than or equal to negative 3. And then, you guys, I am just going to choose one other point. I'm going to go up on my table. I'm going to go choose negative 5 comma 10 to give me another point to graph. Negative 5, because it goes on to infinity, right? So I'm going to go to negative 5, negative 10. So 1, 2, 3, 4, 5. Negative 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right here. And I have this, and Kyle asked, what do you do? Put an arrow on the end? What do you think?
Yes.
Yeah, because I'm going forever in the left direction, which it means it's going to continue forever in the up as well. And that's what my piecewise function looks like. Eddie. I'll show you one in just a second. Yes. Why does it go to negative 6? because when you mix in this 2x in the middle right here, it changes everything to do with that. Like on these functions right here, that one right there moved it up 3. This one moved it down 2. So you're asking, why doesn't that one move it down -5? It's because this 2x right here is going to change things in there. It's going to change where it shifted to and so forth. It's going to change the amount it goes up or down. You actually should have learned that in Algebra 2, but maybe we'll review it a little bit this year. Yeah. Well, if I give you the fast version of that, have you ever heard of completing the square? If you complete the square, what you do is you take the constant out. You take half of 2 is 1, 1 squared is 1, and that's the number you need to complete the square. But you can't just add 1 to the right side of the equation without compensating for it, because you're changing the value. So you got a -1 as well. Okay? This factors to be x plus 1 times x plus 1, which is x plus 1 quantity squared, and -5 minus 1 is -6. It shifts it to the left 1. That x plus 1 shifts to the left 1. That minus shifts it down to 6. And that's why it started at 6, down there, -6. So that's the fast answer to that. It's a little bit off subject, but since you're asking, it might be a good time to talk about it. Okay, but back to this, you guys. So right here we have what's called a piecewise function. All eyes right here. This is a really important point. Okay, the question is this a function? Do you remember how to tell whether a function's a function? Vertical line test. Does it pass the vertical line test? Does this pass the vertical line test? Yeah, look. This one only crosses one at once, right? If I go right through +1, that hollow circle means it didn't include that point, so it didn't intersect there, but it intersected right down here at 1, 1, right? That's why we had to have hollow circles in some places and solid circles in others. Because right here, it crosses that one, but not that one. Say that again? Yeah. Does this all make a function? Is a question Eddie is asking. Does it? Yes, it makes a function, okay? Here's what this is called, you guys. These are called piecewise functions. Write this down in your notes. Piecewise functions. If a vertical line crosses a graph more than once, then it's not a function. But there is nowhere where it crosses this graph twice, because even like right here, it crosses the function right there at that point, but down here, that's a whole circle. That's not included in the function. So no matter where you put a vertical line, it's a function. I restricted the domain so it only hit certain parts. Not yet. Just a second. I'm almost done. Okay? So this is called a piecewise function. Now, I want to show you guys how they would write this in the book. See how I listed it as function 1, 2, 3? I listed them as 4 different functions, and I showed the restriction 4 different times. There's some notation for writing this all as one function. And so that's what I want to show you guys right now. You guys, I'm going to go another page. Do you guys have these written down? Anybody? Can you tell me what they are, Miranda, when I go to the next page? This is how they would write it. F of x equals, and they put this big brace like this, and they start off. The first one was x squared, right? What was the next one? X squared plus 3. The next one? X squared minus 2, and okay, and they list them all like that, and then they show their restrictions. This one was between -1 and 1, is that right? This one was between what? 1 and -3, and it included -3, but not 1, right? This one, oh, not negative, yeah, that's right, 3. This one right here was between -3, it included -3, right? But not -1. And this one, negative infinity Less than x, less than what? Negative 3? Oh, yeah. And on an infinity one, you guys, when it goes to infinity, it will never be equal to. Sorry. Okay? And it can't be equal to negative 3. So this is called a piecewise function. I need you to write this in your notes. Keep your graph along with, or write it down on that piece of graph paper. And this is what you can write down on your bell work too. You know, just say we did this on a piece of graph paper on your bell work. On your bell work, say we did this on a piece of graph paper. Okay? I want you to keep the piece of graph paper as a reference for this piecewise defined function. Now, who was it that asked me, Eddie or Lincoln? Which one of you guys asked me what's a real life example of this? Was that you? Yeah. Okay, what's a real life example of this? Okay, this is a pretty simple example, but piecewise functions do come up a lot. The post office charges 30, I don't know, what's postage rates right now? I can't remember. For just a simple piece of mail, it's like 30-something cents. I can't remember what it is. So we're going to make something up. Is it 32 cents? What is it? A letter. Just a letter. Okay. So postage. Postage for a regular, for a letter is 33 cents, right? So up from 0 to 1 pounds is, let's say, 32 cents, right? From 2 pounds to 3 pounds, the rate is, let's say, 40 cents. From 3 to 4 pounds, let's say the rate jumps up to $1. Kind of getting the idea of this? Okay. Oh yeah, I did miss between 1 and 2, right? Let's go this one between 2 or 1 and 3. Let's make it 75 cents. Okay. I have no idea what postage rates are. From 4 to 10 pounds is $5. Okay. Well, if I graph this, what would it look like? I'm going to give you guys 2 minutes in your groups to discuss this. What do you think the graph would look like? Do a rough sketch of the graph. I'd do it on your graph paper. 5, 6, 7, 8, 9, 10. And over here, $1, $2, $3, $4, $5, $6, $7. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7. I'd relook at your graphs. I don't think any of you had it right. Okay. Okay, Klain is going to show us what he got. And you can explain it. I'm going to probably repeat what you said so the microphone people can hear. Okay, so 32 cents. That line's a little high, but that's okay. Yeah. So 32 cents is right down there. So if the weight's between 0 and 1 pounds, you have a constant line, don't you? Don't you have a horizontal line? Between 0 and 2 pounds, the cost is the same. All the way across is what he's saying, right? Okay, good job. I know. Oh, yeah, the calibration's not perfect. It happens to me all the time. Everybody wonders why I'm not perfect with my drawing up here. That's why. From 1 to 3 pounds. It's a little high, but he's He's doing his best. Okay. This thing's hard to draw with. Yeah. Okay. Good. From 4 to 10 pounds is $5. Okay. That's what it should look like right there. Is that a piecewise function? There's a lot of piecewise functions when you're talking about costs of things. You can make a lot of piecewise functions, okay? Very good, Plain. Jacob says, makes you wonder why they charge it that way. They'd make more money. He's saying they'd make more money if they charged like this, right? In a line going up. You know, if they made it per tenth of a pound, right? Cost or something like that. I don't know why they do it that way, but this is the way they do it. Okay. All right. Huh? Oh, yeah, they could. I'm sure they could. Okay, now graph the two functions for the defined domain. Y equals 2x plus 1 for x is less than 0, and y equals x squared minus 2 for x is greater than or equal to 0. I'm going to give you guys 2 minutes on this one to get as far as you can. I'd use the other side of your graph paper or something like that, or see if you guys can get this one. Keep in mind, x is less than 0 means from negative infinity to 0, right? And x is greater than or equal to 0 means from 0 to positive infinity to the right forever. Okay, go. I'm going to give you a few minutes. Raise your hand if you agree with Eddie. Yeah. Oh, except, yeah. So the line was on the left side, right? And this was on the right side. You should put arrows on the end. Okay, good job, Eddie. And it included, yeah, that might give you some brownie points. So, yeah. Huh? Oh, this one's supposed to be hollow, and this one's supposed to be solid, plain saying. Is that right? Other way around? Right? Wait, x, the line, oh, no, that's right. That's right. He's got it right. Okay. Hey, look, you guys. I found an online graphing calculator. Yeah. Do you guys want me to show you real quick? If you go to, Shannon, will you go to my computer real quick? Go up to the URL bar and type in hurricanehigh.org. Okay, you got it right there. Okay, hey, everybody watch right here. You go to the Hurricane High School website, go to departments, go down to mathematics. There's my name. My personal website's right there. You click on that. Yeah. And then period, where it says pre-calculus period 6B, click on that, even though it's 5. Okay, oh, I didn't put the calculator on here yet. I'm going to put the calculator right here, you guys. See this? I'll put down the calculator right here. I'll show you, though. Go to Secondary Math 3. I put it on that one because we needed it the other day. It says Online Calculator. Click on that. And the one that says right here, Free Online Graphing Calculator 1, you click on that. And there's the graphing calculator. You can type in your stuff right here. You can set your window right there. You can find your table's going to be right over here. Okay? And you can use that calculator online. Also, if you got a smartphone, there's a couple of good apps. If you just type in graphing calculator, there's a couple of good apps on there that you can download a graphing calculator onto. And you can use that as well. Okay? All right, good job, you guys. You guys are doing an excellent job. Okay, here's your homework once again, you guys, in case you forgot. You didn't write it down before. These 4 problems. Hey, you guys, we're going to be studying for a test, reviewing for a test next time, and then we'll be taking the test. Probably on Thursday next week.